Hello, everyone. Welcome to our session number 3 for on GraphQL Architecture Masterclass. And hopefully you are here to learn about what are some of the best practices in order to actually build out awesome GraphQL APIs that your backend teams would love making and your front-end teams would love using. Today's topic is on how to implement GraphQL when your data resides in more than a database. Uh, some of us have built databases in our previous lives, and we absolutely love and adore databases. But we also know that data resides in more than a database. And the question is, how would you actually build out a GraphQL API that works across that? So the two of us are myself, Anand. Uh, I I was there in Apigee as a CTO. Before that, at IBM, doing a lot of fun things in the area of databases. And it's a pleasure to work with Carlos here at StepsIn. Carlos?
Yeah, hi everyone. My name is Carlos Eberhardt, and I worked with Anant at Apigee quite a bit, and since then as well. I don't have the database background that he has, but I do have a lot of API background, and I think a lot of that is still really relevant to GraphQL. Even though there is a fantastic database aspect to it. And then prior to all the fun I've had with Anant over the past decade or so, I spent a lot of time on the enterprise side of the world, building systems and APIs and things like that. So I've got some good background in terms of some of the pain points that you can run into that you may not find if you're just greenfield development on new APIs.
For those of you who are in smaller companies and even in larger companies, you do understand that work can be work, but working with people that you enjoy working with can make a huge difference. And I'll be nice to Carlos here and say, Carlos, it's an absolute pleasure working with you.
Thank you, Anant. I appreciate it.
Awesome. Okay, so we've got 4 or 5 topics to cover. We'll bring all of those things together in a demo, and we'll keep it very, very interactive and try to make it non-commercial, though some of that might leak through. I always like to begin these talks in kind of helping people understand and kind of frame in their mind why they're doing GraphQL. Obviously, the topic for this discussion today is where is your data at that you're kind of bringing together in your GraphQL APIs, and you've got to think about what is the purpose of that API. Is it meant to expose backends, or is it meant to actually protect the backends from the front end people? And what are the architecture choices that you can make? And then Carlos will, of course, do a demo and we'll take live questions. So with that, the key question is, why do you do GraphQL at all? So GraphQL, of course, has been promoted as a much better interface to kind of as much better API, because you can ask for the bits that you want and you get the bits that you want. So here, for example, if Alice is building an e-commerce application, she can come in and say that when John Doe has logged in, can I greet John Doe by his name? So get me the name, and can I understand what the orders are so that I can display all of those orders? So that's awesome. So GraphQL definitely represents kind of a step up when it comes to building out better APIs. But what we have observed is that GraphQL actually has another superpower, that it actually abstracts away all the backend. So for example, the query on the left-hand side can come from 1 system, 2 systems, 5 systems. The person who's consuming it doesn't care. And therefore, the thing for you all to think through is that if you're doing GraphQL, are you doing it for the reasons of the left, or are you doing it for the reasons of the right, or for some combination thereof? Right, Carlos? I mean, when we started, we were just absolutely fascinated with kind of the syntax and things on the left. But as we started to work with clients, we realized that the right-hand side was perhaps as important, if not more important, than just the left side.
Oh yeah, absolutely. In fact, back in the days of REST APIs, we'd work with a lot of companies that wanted to do sort of bespoke APIs for specific use cases, whether it's a consumer application or something for their own internal use, instead of taking sort of their enterprise services and just letting the developers pick and choose from whichever of those they needed and have to get all of that data together. They would start to build specific REST APIs that met those individual needs, and that really is a great fit for GraphQL because, as you said, right, the developer can select just the data that's of interest for that application. But at the same time, with that federation capability, you don't need to build out separate GraphQL APIs for that. You can just have a single API that you build. So on the producing side, it makes things a lot easier as well, especially when you start to pull in different data sources.
Awesome. And having seen hundreds of these backends and the way I like to think about it, Carlos, is that the Fissiparous tendencies of data, the decentralization tendencies of data almost always exceed the ability to actually centralize it and bring it together.
Mm-hmm. Mm-hmm.
Okay, so as you kind of think about this not just being kind of an API syntax, but start to think about what backends kind of come together, you just have to kind of think about it in kind of another dimension. Do you have a backend, for example, a database backend, that is been built bespoke for these applications? Okay, so what that means is that, look, here's some backend that's whose sole purpose in life is to service these new applications that are being built across on GraphQL, and that's one way of thinking about it. Okay, but what we find is a much more common worldview where the backends exist not just for these new class of applications that are being built in GraphQL, but they exist for whatever reasons they exist, and yet they've got to be GraphQLized on top. So again, so you have to just kind of think through whether the backends that you deal with are kind of purpose-built or exist for whatever reasons they exist, and you have to kind of layer your GraphQL on top of it.
Yeah, and on this one, I think this is where my experience in the enterprise, I tend to lean towards the right of this chart, just because I know what the world is like there. But when you're dealing with something smaller, oftentimes, and you're building out a new application or a new service, for example, it makes sense that you start with the data store when you think about things that way. I think over time, you're going to find, and I've seen this happen, that application does, maybe the primary source of data is that purpose-built DB, but it's going to start to need to pull in additional information. And when that happens, you've got a choice at that point, right? Do I want to bring that data into the database, or do I want to bring that data into the API and merge it at the top layer? And I think I've often seen that in those cases, maybe it's an app that suddenly needs like geolocation capabilities, so you need a geolocation API. That's the sort of thing that it makes sense to pull in on top and abstract away from the app directly by merging that into that single API. It gives you the flexibility to change it later, or control it a little bit more without your app developers needing to know how to access that core system. I think the point is, I think that over time, that picture on the left side does start to move into the picture on the right side.
And that is if you start from the left, but often people just start and stay on the right altogether.
Yep, absolutely.
So, and then even if you're starting with picture on the left, if you believe that everything can be and served out of database, there's no one flavor of database, right? So you may be in love with Postgres, just awesome. Love Postgres a lot, Carlos. I think you know that I was there doing my PhD at Berkeley, even though I didn't kind of help build out Postgres, but a lot of work that I did informed some of the things that happen in Postgres. But Postgres is not the only database out there. You could have relational databases, just kind of given a list of 4, and I'm sure that some people who represent databases will get offended by what I've missed out. But then, in addition to kind of relational databases, there are these non-relational databases, right? There are these NoSQL databases, Mongo's, DataStax, Couchbase, and whatever have you. So even if you kind of think about your data and sitting in a database, almost always there's not one flavor of database that you are dealing with, and your neighbor or your friend or somebody else is probably dealing with something that's really really different. So the point here is that the kind of the backends tend to get varied, even if you've got kind of a database centric worldview, and you have to be able to build GraphQL across all of them. So one of the questions, for example, that you might want to ask is that if your data sits in a kind of a NoSQL database, what is the structure of GraphQL on top of it? And Carlos, I know that you encounter this day in and day out as you work with our customers, right? But very nice entity relationship model of a relational database can in most cases be GraphQLized. Though of course you have to GraphQLize a MySQL and an Oracle. But now when you start to think about records that have some common fields and some not so common fields, et cetera, which I've shown in the bottom, then you've got to kind of think through how do you take what is slightly looser in the back end and represent it as a very strict type system in GraphQL.
Yep, absolutely. And I was just doing some work related to this the other day.
I know you were.
There's a lot of and this happens with SaaS services as well, that you end up using it with a REST API. You're not necessarily getting a strict type back all the time. Some of them are better than others, so there's flexibility that needs to be in there. So I think what I've sort of followed from a practice on this is to strictly type as much as possible and be flexible enough to make that grow over time, because I think that does enhance the capabilities of your API. If I do, if we're looking at this picture, if I can make sure that I have types for all the greens, that's great. And then as I learn more, maybe the yellow is something a little bit strange and I don't quite know what that is, but I can have optional types for the reds and the blues, so that my query, when I'm selecting fields on that type, I can know what's available, and I can, then we can use the schema to include documentation so people can understand what it's for. And then there's always sort of an escape hatch of, if when you're implementing your GraphQL API, you implement, and many GraphQL servers have this, or you can implement yourself, a scalar called JSON that just puts out the JSON data into that field. That works, and it's accessible, and it allows you to pull in sort of that unknown set of data that might come back, so that at least it's there in the API, even if you can't necessarily navigate down directly to those fields that you want. Being able to do something like that, so that you've got the capability to pull that out. And we even see that sometimes in databases. Postgres has a data type called JSON, so you can just put JSON into a field. So you need to kind of have your GraphQL API needs to be able to deal with that, just so that the data is available.
Okay, so the point of all of this is that, look, your backends are varied. They may be database, they may be non-database. Within the database, they may come in different flavors. And as you think about how you build out the GraphQL API, you've got to understand that heterogeneity, either within a database or across databases, and build out an API that the developers who use that system really, really love. Furthermore, you've got to think about what is the shape of that API. Okay, so we've just talked about kind of what the backend data looks like. But for example, you could build out an API on a database that kind of exposes all the kind of SQL flexibility into GraphQL. For example, in syntax, which might take where and equal and everything else, and can allow the consumer to actually access the data in whatever shape and form that they really want it to do. But obviously, at that point in time, the cognitive overload on the consumer of the API is much, much higher. Or in contrast, you could build out an API that is really consumable, But what that means is, as an API builder, you've got to be thoughtful. You've got to understand what are the patterns, and you've got to kind of be able to build out that API that kind of supports that pattern. And what that does is that your initial thought, as they say, your measurement before cutting pays huge dividend further down the road, but that does require some additional work. And so what you've got to fundamentally figure out is whether your model for API is a left model or your model for API is a right model, and whether you're paying now or paying later, and who is actually getting that kind of cognitive overload. And Carlos, you and I have talked about this a lot. We do believe that the starting point should be something on the right-hand side and then add some flexibility, as opposed to a starting point being on the left-hand side.
Yeah, I think, and this goes back to kind of my attitudes about APIs in general. I come from a long line of APIs all the way back to XML RPC and SOAP and things like that.
Yeah, my sympathies.
Yeah, thank you. Those were extremely capable and powerful things. I've how I guess detailed a SOAP payload can get, and how specific, and the types of things that you can make happen. The challenge with a lot of those is that the usability starts to suffer, and I've always been a big fan of how consumable and how usable is an API, and the less, as you say, it's kind of cognitive overload you need to do to get to data, is the better. So for in the example here, if I can query on customers, that's great. And if I want to look for customers in a specific city, this makes a ton of sense to me. Oh, city, Miami. Now I see the customers with that. That said, there's certain tables that you're working with, or certain data types. There may be lots of different fields that you can search on. And even in that case, rather than kind of just opening up everything and saying, yeah, just throw a query at us and we'll try to figure it out and get you some data, I think it does make sense from a usability perspective, and also from a security perspective, to think about how you want to allow people to get at that data.
Yeah.
There are certain queries that you're just, maybe I don't want someone to accidentally kick off a full table scan because it's a really big table. And if I just let them kind of write SQL against it, that is certainly something they might be able to accomplish. So I think your point is where to start, for sure, is with curating, keeping it simple enough to meet, what you understand the needs are. And obviously, depending on who you're building the API for, and whether it's, you're building the one that you're using yourself, or you're building it and you may have other people in the company using it, you can start to capture feedback and understand patterns, and start to then create kind of those filter capabilities, rather than, perhaps doing it just with a, field by field on that. Maybe there is a filter like capability that you create on the left-hand side, but rather than being open, you're using GraphQL types to specify specifically what's allowed. So there's a list of fields that I can filter on, rather than, a filter with a field name and I can put anything in it. So you can do that curation sort of at a very controlled and simple level, like on the right-hand side, but you can also curate the flexibility that you create too. And I think doing, that curation step is kind of a key thing to building a good consumable GraphQL API that people will like to use.
Carlos has so much of perspective here that this kind of short form will not do justice to it. But let's move on, Carlos.
Yeah, that's fine. Sorry, I can go on for this. I'm opinionated about this one.
Let's move on to a couple of other points. So
Yeah.
again, so now, given this, that it's not just about where your data is, but what is the way in which that data gets consumed. The key thing for you all to think through is whether the API and the model that people are consuming it, does it leak the kind of backends? So for example, how you actually, sorry for a bit of clutter here, the way you actually consume a database data versus an API data versus a GraphQL data is different. And then what that therefore does is it might make it very easy for you to kind of create those APIs, but you have just pushed the burden down to the people for whom the API was meant. And therefore, some thought that an API should be consistent across the backends requires some thought and some decision making and others, but then it pays huge dividends because the person who's consuming it is not going left for backend A and going right for backend B.
Yep. Yep. Just like with the kind of the earlier slide talking about the design there, this slide makes me think of another reason to do this that I don't know that we've talked on a lot, and it's basically that idea of your back end details kind of leaking into your front end, and that's I've always felt is a dangerous pattern to start adopting, because anything that lasts a long time is going to go through change. And often you're going to find, and we're working with a customer that's doing this right now. They've got one SaaS service and they're moving to another one for a bunch of their data. And it turns into a lot of work when you let those details kind of seep into the consuming side of that data. So
Yes.
doing this curation level not only makes it nicer for the users, but it does make it nicer for you as well when it comes eventually, inevitably, time that one of these systems moves or migrates or upgrades, and something about it changes. Having that layer of GraphQL where you can essentially map and shield those backend changes from the consumers is super valuable. Super valuable. I trying to think of good examples. I know in the past we used a mapping solution at one company I was at for a mobile app to display maps. And for whatever reason, I wasn't involved in the choice. The business decided, well, we're going to switch to a different provider. And that meant, that's a huge chore, because you've got mobile apps in the hands of consumers that now need to go through a full release cycle and testing and upgrades. And you can't switch over providers until you know that, you're pretty confident that nobody's using the old version, which is not easy to do with tens of thousands of users of a mobile app. So having the ability to abstract that away, and the mobile app API stays nice and clean. And this was an API, not GraphQL, but it applies the same. And being able to swap out that implementation on the backside, it saves you so much effort in the long run. And then I think it's there are pros and cons to that when you think about starting that way, because as you said, it's kind of easy to just sort of jump in and make, hey, we'll just transfer this into an SQL query and there we go. And then, suddenly you find that your database isn't scaling, or you need to move to NoSQL for some reason, and your query language changes. And now you're pushing that change everywhere that API was used. And that requires, if you just think about the amount of testing that needs to be done and the orchestration for how are you going to roll that change out? That's a big deal. It's a lot of work.
Absolutely. Okay, so we actually have got a very opinionated view in terms of how you should therefore think about it. All the discussions that Carlos and I have had till now lead us to these kind of 4 points that we believe is the best practice when you're dealing with multiple backends. One is you need to curate the schema that we have discussed a lot. Of course, you need to make sure that the curation doesn't kind of harden it so much that it becomes useless and people can actually evolve. So you need to allow for some flexible query. But most important part of that curation is to keep the syntax as simple as possible. And then if you turn your attention to the right-hand side, consistency across the backends is really, really important for the reasons that Carlos talked about. So how can you take, if you have a database or a new SQL or a REST or a multiple combinations of this, how can you actually build out an API that doesn't leak the backends and is kind of completely consistent across? So we actually strongly believe, and of course our product pushes in that direction, but we actually strongly believe in these. And then whether you look at steps in or don't look at steps in, these are kind of core principles that we believe you should follow. Okay, so enough talk. We should switch to demo. And obviously, in terms of consistency, Carlos, you can show a lot of things with respect to consistency. But I think today you have picked something specific, consistency in pagination. So why don't you tell people about why pagination is important and how to make it consistent and how StepZen does that?
Yeah, sure. So let me just refresh my steps and dashboard here. I have a little demo API that I wanted to look at that we could talk about pagination. And the reason I chose pagination for this is because it's something that sometimes gets overlooked, I think, when you're kind of diving into queries, and because sometimes it's so easy to do. REST APIs often support it, so it's pretty easy to just map what they support into your queries. And databases, when you can write queries, you can paginate in various different ways, and it's easy to basically take whatever data you need from to feed into the SQL query and put that into an argument for the pagination on your GraphQL API. The challenge, I think, comes in, and this is kind of back to the slide where we looked at backend details leaking into your API, is that when you start to bring these things together, how do you make them map up when they're very different models of paging? And that's one thing I wanted to look at here, and we'll look at some of the schema to do this, but the schema is not necessarily the important part. The important part is what the experience of the API is. So that's where I wanted to start here. So for this example, I have a query where I can pull up customer details. It's a database. I think there's a couple in here. There's a few hundred records in there. Obviously, something if you're pulling up a lot of information, like if I wanted to pull up orders and status and order date for all my customers. Oh, Union Pacific doesn't have any. Let's grab a different one here. For all my customers, that would be a lot of data. And if I'm going to put that on a mobile app, for instance, or web app, I'm going to end up wanting to page through that. So I could write a query that just says, hey, start next and do my offsets and limits in the SQL. But GraphQL does have a specification for paging. And if we, instead of just kind of hand rolling our own paging stuff, if we work with our schemas to support the GraphQL definition of paging, then whatever query I'm executing, GraphQL query, whether it's hitting a database or an API, the interface for paging is the same. So my consumers, my developers, have a method for paging that works regardless of what type they're paging across. So let's look at, get rid of this customer one. Let's look at customers here. And the way GraphQL paging works is that there are connections and edges, and that's so it looks a little bit different, but once you get used to it, it's very, very powerful and nicely consistent. So if we wanted to grab, say, the first 50 customers, I'm going to want to look at whether or not there's a next page and an end cursor. And this is what tells my application code, whether or not I can retrieve more or not, and how I retrieve that. And then the data ends up living under something called a node in my edges. So if you think about a graph, it's got nodes and edges. That's where this comes from. So again, here I can get customer name, I can get the orders, and I can get the order date and the status. So the query, the data shape, again, is the same. Once I get down into that node, it's identical. So here I can see, it looks like now, yeah, there's about 50 probably, if you can count fast. There's about 50 customer listings there. And I can see, here's an end cursor that tells me how to retrieve the next page. If I wanted to grab that and retrieve the next page, I simply use this in the after field. So it's very easy for the consumer of the API. They don't need to know customer IDs. They don't need to know, where that data is coming from. They just know that they're pulling in the next set of pages, and there's still more pages, and we could grab this cursor and go through and through to retrieve all of that data. So it's standardized how to understand if there's another page, how to ask for the next page without needing to go and figure out the counts or anything like that. And obviously, if all I had was a database, I could do this or I could not. It doesn't really matter at that point from a consumer side, because if I didn't do this, I would have a standard way of paging through the same database. But when I start to mix systems and pull in different things, so instead of looking at customers, for example, if I look at tweets, now the Twitter API doesn't do like a first and a next. It does first, I guess you can grab anything between like 10 and 500 or something like that. But it doesn't do you know, a a numbered chunk of like a skip. Like I can't grab the first 500 after 200. What it does is it actually returns a cursor. It does something um, a lot like what GraphQL does. But that cursor comes in, you know, it's not GraphQL at that point. So if I do a search for cursor or for GraphQL, and I'll grab the first 20, and again, I can get my page info to see if there's a next page, and I can see the last cursor that I had, so that I know where to grab the next page from. And again, I'm coming into nodes, and we'll just grab the text on this one. So if I fire this off, again, I see the same type of thing. Is there another page? Yes. Here's the cursor to use to retrieve that next page. And then here are the tweets that are coming in here. And I thought we'd have a StepSend one in there, but I'm missing it. There must be enough people talking about GraphQL. The last time I looked, there was a StepSend one.
Okay,
so
awesome.
Again,
so Carlos, just to kind of make sure that I understand what you've shown,
yeah.
What you've said is that look, there is a way in GraphQL to paginate through data, but now you've got to take whatever are the backend mechanisms. In the database, it will be a SQL query with limits and offsets. In the case of Twitter, it will be kind of whatever the Twitter weird specification is to get the right kinds of data. And we've got to map all of it into kind of a consistent form. So the person who's consuming Twitter data versus consuming order data, she doesn't care where the data is coming from. There's just a uniform mechanism by which she can actually consume it.
Exactly right. If we didn't do this GraphQL pagination with a GraphQL API that had Twitter data and database data in it, I would have to have two different models of paging.
Yes.
And that gets, you know, just, is it impossible to deal with? No. Is it obnoxious to deal with? I think so. Especially when you're building, you know, the way we build web apps today, we reuse so much code, and the frameworks are so consistent. Having to mess with how I do paging, depending on the data that I'm getting, is pretty obnoxious.
Oh, that's awesome. Hey, listen. So there must be some magic that StepSend is doing behind the covers to kind of take kind of a uniform abstraction and make it into bespoke things. So if you can just kind of flash what that magic is, if you have it ready,
sure,
and then we can move on.
Sure, I do have it ready, believe it or not. I can show you what that looks like. So let's start with the database one. The key thing with GraphQL and pagination is that you need types to support the connection and the edges. And so in this case, I defined two types. This is standard GraphQL schema. There's nothing unique in StepSend about this. If you were writing your own server, you would do the same thing. You would create these types and connections, and the connection is used as the return type for the customer query. So here's my customer query that uses a customer connection type. So instead of just spitting out an array of customers, I use this customer connection type in my query. And now this is the part where StepSend comes in. And essentially, this is no different than any other time we connect to a database. The trick is that the StepSend server, when it sees this schema and sees that you have a first that's an int and an after that's a string, and the type that's being returned from this query is a customer connection, then it says, we're doing GraphQL pagination. So what I need to do is I need to translate that long stringy token
into an offset.
Into this query. So awesome. That's a little bit of StepSend magic. If you weren't using StepSend, you would have to write the code that did that.
And you'll probably need to put a hash table on the side that will convert limits and offsets and all that stuff. Okay, awesome. So we can convert pagination into database. What do we do with REST calls?
REST call, same thing at the start, right? We need those edges in the connection type because that's the standard GraphQL pagination. We change our query. Again, this could be, you know, I might, instead of having tweet connection, this might be a list of tweets that comes back. The trick here is we need to tell StepSend, how do I find, first off, what type of pagination is this API using? Yes. Is it using offset pagination? Is it using something we call next cursor pagination? In this case, Twitter's using cursor pagination. So then we need to tell StepSend, okay, awesome. Where do I find the next?
I got it.
cursor to use and what's it called. And in this case, Twitter returns in their JSON, they have a meta object that has next token. And then we do a little bit of extra trick here. We say that my argument, because I do the same first and after, what I need to do is take that argument of after that's coming in on tweets and convert that into next token before I pass it back to the API. So
Awesome.
That's what that line does.
Yeah,
So two lines of code.
Yes. So exactly. So just to make sure that our audience understands, right? So Steps In believes in kind of declarative power of GraphQLizing backend. So what we showed you were kind of two snippets, which kind of took that same construct on the top and declaratively constructed the SQL query on one side and the right REST call to Twitter on the other side. And with all the mappings and others as the hard work that we did for you so that you don't have to do it on your own.
Yep. Okay. But the only thing I'll say is that if you wanted to do this pagination, it's not, this is GraphQL. So I think it's a good idea, even if you're not using Steps In, to use GraphQL pagination. You just need to do the work to implement it.
Exactly right. No, exactly. So the point is that consistency is really important.
Yes.
And consistency across backends is really important, but there's hard work involved in making it consistent. And just a bit of a plug for us, Steps In makes it easy. Okay. Awesome. Are you done?
Perfect. I am done. That's all I do.
Let me move on to, okay. And I don't look like Steve Jobs, but I want you to just kind of pretend to take out an iPad Nano from my back pocket. So there is one more thing that I wanted to tell you guys about, that once you start to think about these multiple backends, that they don't look like just relational tables. It turns out that a table-based optimizer that treats everything as kind of flat structures doesn't exactly work. And that's why we believe that a kind of an optimizer that optimizes around hierarchies and JSON structures that come across from various backends is the right way of doing it. And that's one of the things that we've done in Steps In. And therefore, we actually have built kind of a purpose-built optimizer that is in Golang that runs outside the backends, because we can do all the magic that's needed. And the point here really is that once you start to think about multiple backends, you've got to think about not just execution of the query, but optimal execution of the query. And then you require a query optimizer that needs to kind of think about the various shapes and forms and do the right things.
So, and I'm sorry to jump off script here a little bit.
Yes, no, nothing.
We don't really have a script. Is what we do with what we call memoization? Is that an example here of something that would fall under this GraphQL optimizer?
Yes, and what memoization for that's kind of a computer science jargon, but the idea is that in your GraphQL, you may end up you may need to make the same call to the backend, but from kind of two different paths. So how can you remember that you've already executed this and reuse it, right? That's an example of some kind of complex tree mapping and tree analysis and other things that we have to do and that we end up doing.
Sure. So at any branch of that tree, say I'm down inside my graph and I'm pulling out, I'm using a query that says customer and the ID is 5. Once we do that and we see that once, we memoize, if that's the right word, that
is right, the word. That's
that
right
result.
Word.
And then if we see that somewhere else, because you can get at those things different, right? I can get at customers through orders, or I can get at customers through just customers. We'll just reuse what we've already found as a result for that data, rather than re-executing, whatever backend system was going to need to pull that out.
Exactly. And there are many other optimizations. But anyway, the main point here is that once you have multiple backends, you need to kind of optimize the execution against them, and requires a lot of thought and just kind of converting your GraphQL query into a SQL query and executing as a SQL doesn't quite work.
Yeah,
and that's what
I can see why there were. I've always been a little surprised at some of the concerns about performance and optimization and things like that, until we start to dive into it like this. And then you can see if I'm having to write code to do this, I'm actually, it's not me who's doing it at that point, right? I can write some code, but I'm not going to be writing the code that optimizes that. That's a hard problem. I get it. Yep. Makes sense.
Awesome. So, you can have consistency for security. We actually had a talk that I wasn't there, but our CTO and Carlos were there. So go and check on that. But the essential thing is that the minute you start to think about your database is not Postgres or your database is not MySQL, but you've got different databases and you've got different backends, you've got to think about all the things that hopefully we have brought out for you today.
Yeah, and that just quickly on that talk,
yes,
you weren't there. It was fantastic, but not
because I wasn't there.
Not because of that, but one of the things that we like to point out, and I think Sridhar maybe brought it up, was that by sort of abstracting the security and not letting the back-end security details leak out into the GraphQL side, and doing that thoughtful curation of your schema with an eye to security as well, you end up with something that's a lot more secure and a lot easier to maintain. And I think that just kind of reinforces this idea of curating your schema rather than just generating it.
Awesome. Thank you. Okay, so just to kind of repeat the points, you guys, we have made these points. Think about curation. Don't let your backend abstractions leak. Be consistent, and then make sure that you are able to optimize across different backends. You can learn more about some of our thoughts, our architectural patterns, by going to the links here in the video. And let's see if we have any questions. And so let's take a look if there were any submitted questions.
Yeah, if we don't, maybe you could do a quick little whiteboard coding exercise on memoization for us, how that works.
Yes, exactly.
Yeah.
Thank you very much. Thank you very much. Absolutely.
That sounds like black magic to me, I guess. It's fantastic.
It's voodoo economics. Okay, awesome. Hey, so hopefully we have kind of talked to you about how you need to think about it. Of course, we showed a bit about how StepZen does it, but and obviously we would love for you to kind of continue having these architectural discussions with us. Our next masterclass, which is next week, is on federated data. As you kind of think about building your APIs, do you think about it as one API that covers all the backends, or whether it's an API of APIs, and what kind of choices can you make? And again, we'll talk a bit about the pros and cons of various approaches out there, and then show you a bit of the demo out there. Okay, and we would love for you to ask questions of us on our Discord and sign up. But otherwise, thank you very much. And Carlos, thank you. And I hope that all of you saw that not only do we think through GraphQL issues, but we are building a product that addresses the pain points that we have seen, and we enjoy working with each other a lot. Carlos, since I praised you so much, maybe you may return the favor also.
Oh,
but
gosh,
no.
Well,
hey, just kidding, man. Just kidding.
Now you've asked for it, so I have to. No, this was. I thought this was a good one. I really. This is one of those things that I'm always. You know this, that when I'm trying to do some work for customers or something with the database and trying to figure out how to solve a problem, you're kind of my go-to guy on that in terms of
oh, shut up. I didn't. Okay, no, please.
No, it's true.
Okay.
It's true.
Hey,
because you know so many things about that, and that's, I think, one of the things that maybe doesn't come through in some of the other things that we do and necessarily in the product, because
God,
a lot of that is under the
now you're right? On my brown skin, I can't turn red that much, but I'm turning red. Okay, awesome. Hey, listen, thank you very much, and have a great day and rest of the week, and do challenge us and question us, and we'll build a better GraphQL future for everybody together. Thank you very much.
Awesome.